You are with Cape Talk.
Views and news with Clarence Ford.
Welcome back. Before we go to the Naked Scientist, loads of questions in about the price of batteries or the replacement of batteries for electric vehicles. There is some data out there. I can tell you my information is that it may need replacement at about 300,000 kilometer ownership mark. And it's very expensive at this moment in time, my information suggests. But 300,000 Rand is going to be a good couple of years of driving. And who knows, maybe just economies of scale bring the price of those batteries down in that time. So what you lose in the roundabout, you gain on the horses. I guess it's like that. Dr. Chris Smith knows everything. Maybe he can guide us on EVs as well, since it's such a hot topic. It's time for the Naked Scientist, consultant virologist at Addenbrooke's Hospital, Cambridge. Dr. Chris Smith joins us from the UK via Zoom. Welcome, Chris. Always great to have you on a Friday.
Good morning. Yeah, well, as someone who's got an electric car, this is obviously something foremost in my mind as well, because it's a big investment. These things are really expensive. And then you think, well, how long is this going to work for before we see degradation of battery performance? But the evidence is I'm 6 years down the road now with mine, and I haven't seen, and I'm about 50,000 miles or so of miles travelled. I haven't seen any demonstrable deterioration yet. Now, they say they go at least 100,000 miles, so a couple of 100,000 kilometres, give or take, before the guarantees run out on lots of these batteries. So the manufacturers are confident that their technology will stand the test of time up to that point. But that doesn't mean they suddenly stop working. It's not like today it works and you trip over this magic mile and it doesn't. It's just that the performance of those batteries will deteriorate, and therefore their ability to deliver the range that they did will deteriorate a bit. But it's not night and day, and it's not abrupt and all of a sudden. You're just going to see a gentle kind of slide. And most people are expecting their cars to show performance degradation with time in other respects anyway. So at the moment, I think the jury's out, and it's not something that is giving me sleepless nights. And I haven't yet seen any evidence, as I say, 6 years down the road, that I've got big problems. So watch this space. I think it's one of those things that we worry about, we think about, but we don't have to panic about.
Apparently, some real-world fleet data shows that degradation is occurring at about 1% to 1.5% per year.
That sounds about right. I mean, the thing that makes batteries die is when you really put stress on them. How do you stress a battery? Put huge power demands on it. So putting your foot to the floor, pulling away really fast, very tempting in an electric car because it's got the performance and it does feel good. But that puts enormous current through the battery, which causes degradation. Also, charging them up really hard at really high power densities. When you plug into these super fast chargers, the batteries are designed to take it, but at the same time, it does wear them out. And if you trickle them, slowly recharge them, that helps. The other thing that makes a difference is if you stress the battery at the extremes of charge. The sweet spot is somewhere in the middle, about 70 to 80% maximum charge. If you have to really eke out that extra bit of range and push it up to 100, you can do that. You'll get a bit more range out of your car, but you will be stressing the battery more doing it. And at the opposite end, if you over-discharge or push the battery to discharge right down to the bottom of its boots, this also stresses the technology. This will accelerate deterioration. If you don't drive aggressively, if you don't charge aggressively, and if you don't run at the extremes of charge, that is consistent with the best battery lifetime and sustained performance into the future, as far as we can tell at the moment.
The Naked Scientist, we're looking for your questions via WhatsApp at 072-567-1567. You can call, you'll jump the queue on 021-446-0567. Solly, Dr. Smith, earlier Clarence was talking about electric vehicles. My question is, why are EV fires so dangerous and almost impossible to put out?
The reason, Solly, is because the energy source in an electric vehicle, it's largely all based around lithium batteries, various lithium chemistries. So when we charge these batteries, you are basically pulling electrons and charged particles on and off of other surfaces. And in the case of these batteries, lithium, they use that because it gives a very good voltage performance. It gives a very good energy density. The amount of energy you can store per weight unit in those batteries is incredibly high. But lithium is a very reactive metal, and a bit like sodium, if you drop sodium into water and it fizzes, lithium is just one stage further up the periodic table in terms of its reactivity. So it does want to react, and it will do that very nicely with air. And when these batteries operate, they get hot, and heat drives chemical reactions. So you've got this sort of potential for a vicious cycle where it gets hot, that can get the lithium going if it's got air access to it or water gets into it, and then the reaction makes even more heat, which makes the reaction go even faster. So it can be very hard to stop once it's got going, and there's a lot of battery lithium. You weigh these cars, the big electric cars probably weigh 1.5, 2 tons, some of them, and half of that is batteries. So that means a lot of lithium in there, a lot of fuel to burn, and you can't just put water on it, as I say, because water will act as an accelerant. It will actually react with the lithium and can make the situation worse, because the lithium reacts with the water to make hydrogen, and the hydrogen then burns, so they're not trivial to put out.
Okay, question from Anne. Has there been any major advances regarding AFM, acute flaccid? I think it's myelitis, not quite certain.
Myelitis, yeah, acute
myelitis.
flaccid paralysis and AFM, yeah.
Especially regarding regeneration of spinal nerve cells. Yeah.
Okay, well, AFM, or this is where a person will develop paralysis in a segment of their body or below a certain level of the spinal cord. So if you think about my legs are provided by nerve supplies from the bottom of my spinal cord, my arms from the top, and so on. So you can get a level where if there's damage to the spinal cord, everything below that level can have impaired movement and also impaired sensation. This happens for a range of reasons. Trauma is probably the most common, where a person has an injury which damages the spinal cord and it severs the tracks, the nerve pathways, a bit like cutting wires on a circuit board that carry the information down your spinal cord to the nerves that control muscles. This is very, very common, and one of the reasons that it causes lifelong problems is because when this happens to you, unlike the peripheral nervous system, nerves in your fingers, hands, toes, arms, nerves in the central nervous system, your spinal cord and brain, when you injure them, do not regenerate. They don't grow back. So injury there does tend to produce permanent disability to some extent. So that's the first thing. Trauma can do this, but also inflammation. Inflammation can be caused by your own immune system, and some people with acute or chronic inflammatory problems caused by immune attacks on targets in their nervous system can get paralysis. Multiple sclerosis is an example of this, where the immune system attacks the coating around nerve fibers. This is called myelin. And if you have relentless attack on certain parts of the nervous system, it does damage nerve fibers running through that area, and that can cause paralysis and sensory problems. And then there's also infection. There are certain viruses, and the enterovirus family of viruses, which includes polioviruses, they have a natural tropism or predilection to go into the central nervous system, and particularly the parts of the central nervous system concerned with movement. And in some people, for some reason, they can cause devastating damage, and this will lead to permanent disability. This is why polio used to cause paralysis, because it would attack the motor neurons in the spinal cord that provide access or provide the signals down to your muscles to help you to move. So we know that while polio is nearly eradicated worldwide now, there are other members of that viral family that do still nevertheless cause these problems in some people, and when they do, they can cause problems that are temporary and then a person recovers, or they can cause permanent disabilities. So it really comes down to what is causing this person's underlying problem. Is it something reversible, where there's some inflammation that when it goes away, things are going to get better? Is it traumatic, where there'll be some inflammation, which will make things worse to start with, but then things will clear up, and then there'll be probably a bit of disability, depending on how bad the initial injury was? Or is it something that's caused permanent, devastating destruction of nerve cells, perhaps an infection, and the recovery from that may be more limited? So really it's going to come down to what has caused this in the first place, what the underlying mechanism of the disease therefore is, and that will dictate the treatment, and it will also dictate the prognosis.
Let's go to the voice notes couple, and let's go to Ingrid's one first, Joe.
A question for Dr. Smith. People seem to feel anxiety in different parts of their body. Some people feel it in their gut. I, for example, feel it at the top of my lungs. What accounts for this?
Hi, Ingrid. When we get anxious or stressed, then obviously that is a mood problem, and this is an emotion. But what it does is activate the alarm system in your central nervous system. You have a structure called the amygdala on each side in your temporal lobe. This is about the size of an almond. And this cluster of nerve cells, when activated, triggers sensations of alarm and triggers defense mechanisms. And your defense mechanism is your fight or flight reaction. This is coordinated through your sympathetic nervous system, part of the autonomic nervous system. And when that activates, it turns on all of the measures that make you able or equipped to run away or turn and fight. What do these include? Well, they speed up your heart rate, they put up your blood pressure, they open your pupils wide so you can see get a lot of light in, so you can see far but not close. It makes you breathe much faster and harder, and this is why people feel a bit lightheaded when this is happening to them during a panic attack, for example, because you breathe too fast, blow out too much carbon dioxide. This makes your blood too alkaline, and that makes you feel woozy and unhappy and unhealthy, and the sensation of your heart beating too fast in your chest. Also, people think, well, I'm having some kind of heart rhythm problem, or I've got palpitations, and this is unnerving in and of itself. When you activate this sympathetic response, you also deactivate the counterbalance to the sympathetic nervous system, which is the parasympathetic nervous system. This is the other branch of the autonomic nervous system, which does what we call rest and digest. So when you're relaxed, when you're calm, when you've just had dinner, your parasympathetic nervous system dominates. This has all the reverse effects of the things I just said, and it activates your intestines to help you to break down your dinner. Well, if that gets turned off by a very powerful drive to the fight or flight response, you relax all of your intestines in your stomach, which creates that sinking feeling in your abdomen or butterflies in your stomach as everything is turning off, because you're diverting resources and blood flow away from your internal organs to your muscles so you can fight or run away. So when you bring all these effects together, you see that what is happening is that your perfectly normal reaction to a threatening situation, stress or anxiety, activates these mechanisms designed or intended to keep you safe, but in the process they produce symptoms which we in our stressful situation can interpret as something wrong with that part of the body, and we focus on those symptoms which tend to dominate in different parts of the body in different people, and that is what is accounting for why you think my chest feels strange. It's probably because you're breathing a bit faster, heart's going a bit faster, blood pressure's a bit higher, and that sinking feeling in your stomach because you've turned off all your intestines.
Let's go to John, a voice note for Dr. Chris Smith, the Naked Scientist, at 9:49. Don't forget your WhatsApp messages, 072-567-1567.
Hi, Clarence. Please ask your doctor, good doctor, why is it that if you stand on one leg, you close your eyes, you kind of lose your balance, and as soon as you open your eyes, you can actually get your balance back? How does that mechanism work? Thank you.
This is actually quite a common neurological test that neurologists do, because what you're relying on to stand up straight is signals coming into your brain and your balance system from several different sensory systems. When I'm looking at you, I'm getting a view of the world which is in a straight line. So my eyes are telling the balance system that my head isn't moving. My vestibular system, which is the balance system in the inner ear, is also telling my nervous system which direction my head is moving in or not. Coming up from my body are signals from my legs, which are sensory nerves, which are in the skin, but also critically in muscles. And these nerves can tell how stretched or how long muscles are and how much the muscles are changing in length. This is called proprioception. All these signals integrate in the balance systems in your brain stem and are used to keep you standing straight, because the body is comparing where it thinks you're going with where all those signals are saying things are going, and it then creates compensatory muscle movements to keep you standing upright. Now, if you take away some of those sensory systems, or turn off some of those sensory systems, or deprive the nervous system of some of those sensory inputs, so you close your eyes, now you're relying not on vision to balance your head, you're relying only on those balance organs and the muscle signals. If we take away one leg by making you stand on it with your eyes closed, now we're relying on just the sensory feedback coming in from the skin and muscles and tendons of that one leg. And you've also got to achieve the balance by making just that one leg compensate for all the movements and keep you standing up straight. So it's a good way to stress the system, both the input side and also the motor side of the system. And so neurologists will use the ability to stand up straight, maintain a steady posture, close an eye, or close eyes, lift a foot off the floor and so on, in order to see how good a person's balance system is at keeping them standing upright. But you're stressing the system very much by relying only on a very limited number of inputs and then the outputs through the muscle of one leg to keep yourself balanced, which is how that test works.
Let's go to Janus. Janus on the line. Janus, we'll appreciate it as quick as is humanly possible. Thank you, Janus. Welcome.
Thank you, gentlemen. Thank you, Dr. Chris. I've got a strange situation. When I close my eyes, I open my eyes, I've got like a flashing experience, like a sort of circle, like a neons coming in. I got a headache from that. Is it from watching too much TV, computers, or cell phone? Why is it like that? Is it a danger?
Okay. The first thing is that I'm going to assume that this is something that's just happened once and it's all gone away and you're all better now, or it just happens from time to time, and that there's no residual symptoms, because sometimes if you get changes to your vision, it can be a sign of mischief in the nervous system, and this needs to be investigated, especially if there are effects that persist afterwards. But most commonly, this sort of thing happens for a number of reasons. In young people who stand up too quickly from a hot bath, for example, you can get flashing lights in front of your eyes and feel a bit dizzy, because as you stand up, you temporarily reduce the amount of blood which is returning to the heart, which causes a drop in perfusion of the central nervous system, and a significant proportion of blood flow goes down your ophthalmic artery, which is the first branch of your carotid artery going into your head, and it will deprive the retina of blood flow just a little bit, and the retina has such a high demand for oxygen that drop in perfusion just temporarily causes the retina to effectively neurologically spasm by sending off lots of discharges which produce these flashing lights, and that's why people see funny speckly lights if they stand up too quickly, especially also on a hot day. But if you're not standing up quickly from a hot bath on a hot day and you get flashing lights in front of your eyes, there are two things that could be going on. One of them is you could have what's called a retinal migraine. And in a retinal migraine, for some reason, and this happens from time to time in perfectly healthy normal people, you get a pattern of discharges starting in the retina. This is electrical activity where, because the retina is effectively nerve cells, specialized nerve cells for seeing, they start to discharge spontaneously, and the discharge spills over onto the cell next door, which spills over onto the cell next door, and it goes across your retina a bit like a Mexican wave goes around a football stadium. And as this wave migrates across the retina, it produces all kinds of funny visual effects. People describe effects a bit like wavy flashing lights or firework displays, but it's only in that eye. The other eye is fine. And you can tell that you've only got it in one eye, not the other, because you can look at something and you can still read text, for example, because both eyes are feeding into that patch of the visual world, and the eye that isn't affected will enable you to see okay. In a migraine, what is happening is that you have electrical activity in a certain region of the brain, which, a bit like it was doing in the retina, causes abnormal activity to spill over into adjacent regions and then causes blood vessels to become initially very constricted and then to dilate painfully. And the constriction is associated with the abnormal activity and the lights that you see, which can include these flashing lights you're describing. And then the pain comes when the blood vessels dilate afterwards. And so it could be, if you do get a headache with this, that what you're having is a migraine, and that's why you've got this effect. But if this is a new thing and it keeps happening, or there are persistent effects, you must get this checked out just in case it's not a trivial thing and there's something else going on.
I really want to squeeze this one in. Let's squeeze in John's voice note. Joe?
Hi, morning, Clarence. A question for the good doctor. Somebody once commented to me that no son is ever shorter than his mother, and I certainly can't think of anyone that I know whose son is shorter than their mother. Is this fact true? Thanks very much.
Right, okay. When we have children, then it's possible to guesstimate how tall those children will be by looking at the interparental height, and it's slightly loaded in favour of the male height over the female height, because on average men are taller than women, so you arrive at an average halfway between the two. But around the world, populations, as we are better nourished, better fed, tend to be getting taller on average. But this assumes that a person reaches their full growth potential. And as we know, not everyone grows up in perfect conditions with a perfect diet and no illnesses. And so a person will have their potential height set genetically by the genes they get from mum and dad. And if mum and dad are both tall, then they're probably going to be tall. And because men on average are taller than women, the sons are on average likely to be a bit taller than their mums. But if there's a problem with illness, if that person doesn't have good quality food and drink, then they may not reach their genetic potential, because you can only grow for a certain period of time in your life. And if you miss that growth opportunity, then your growth plates in your bones fuse and you miss out, and you won't ever get that extra height back. So it's not a given you're always going to be taller than your mum. But if you're a boy on average and you're well fed, you probably will be.
We got arrested there, Dr. Chris Smith, the naked scientist. Such a huge appointment. Can't get to all the questions. Dr. Smith, why does the universe exist? Why am I here? Maybe that's the very reason why you are here, to ponder that question. But I think Dr. Chris Smith is going to need more than the minute available for that particular question. We'll hold it over to next week. It is 1 minute to 10 o'clock, and Orly Kalinga now standing by with Eyewitness News at the top of the hour.